This introductory course explores the fundamental capabilities of modern Agentic Command Line Interface, or CLI, tools, focusing on Claude Code CLI, Gemini CLI, and Codex CLI. This session is designed as a high-level orientation to provide familiarity with how these command line tools are structured and their capabilities, without diving too deeply into implementation details. The session begins with an understanding of what an Agentic CLI is and how it differs from a traditional command line interface. From there, we will examine the typical workflow these tools follow, starting with project initialization and moving through agent configuration, context management, planning, execution, and maintenance. The overview includes commonly used commands such as init, agents, context, plan, clear, and compact, as well as orchestration-related features. The discussion also includes how these tools organize project files, manage user and project context, support custom agents and commands, and allow for extensibility through plugins and tool integrations. Additionally, a structured feature matrix will be presented to highlight similarities and differences across the three ecosystems. The objective is not to decide which tool is superior. Instead, this serves as a foundational guide to understanding their capabilities, terminology, and workflow models, enabling confident exploration in future projects. The Agentic CLI workflow represents a repeatable lifecycle shared by tools such as Claude Code CLI, Gemini CLI, and Codex CLI. The process begins with initialization. You start within a project folder, authenticate, and establish the project scope. Unlike a detached chat, these tools bind AI actions directly to your local repository. Next, we consider the role of agents. The CLI functions as an execution agent capable of inspecting files, proposing edits, and running terminal commands under defined user approval policies. This represents a significant shift from prompt-only interfaces to task-capable orchestration. Context management is critical. Each tool maintains a working context across multiple turns, including the current directory, prior instructions, and the overall repository state. This persistent context enables complex multi-step workflows, such as identifying failing tests, patching the code, and rerunning the suite. Effective usage relies on a solid plan. This involves defining explicit goals, constraints, checkpoints, and rollback criteria. Claude Code CLI, Gemini CLI, and Codex CLI all support iterative planning before any mutations occur. During the execution phase, edits and commands are run in small, verified batches. For instance, you might generate a migration, run a formatter, execute tests, and summarize the diff, all before requesting final confirmation for a commit. Maintenance is a continuous process rather than a final step. It involves reopening sessions, refining prompts, and revalidating the environment after upstream changes. Finally, you can extend the workflow by adding custom scripts, tool integrations, or specific project conventions. This ensures the agent follows team workflows consistently. A practical rule for reproducible agent-driven delivery is to always log assumptions, approvals, and test outcomes. When evaluating modern command line interfaces for software engineering, it is essential to focus on structure rather than brand preference. Across official documentation, Claude Code CLI, Gemini CLI, and Codex CLI all facilitate the same core workflow: initializing a workspace, managing context, planning execution, connecting external tools, and extending behavior. Let's examine their capabilities side by side. For project initialization, Claude Code CLI uses an explicit init command, while Gemini CLI follows a project setup flow within its CLI or CodeLab workflow. Codex CLI also provides explicit initialization for repository and task setup. Regarding multi-agent orchestration, Claude Code CLI offers an explicit multi-agent surface. Gemini CLI provides agentic tasking, though it is surfaced differently, and Codex CLI includes explicit support for multi-agent orchestration. Context management is a critical feature. All three tools provide context and memory controls to ensure task continuity. They also include explicit commands to clear or reset sessions. To manage token pressure, Claude Code CLI, Gemini CLI, and Codex CLI each offer context compaction or reduction workflows. In terms of execution, each tool supports a planning mode or a plan-first workflow. For extensibility, Claude Code CLI and Codex CLI feature native Model Context Protocol, or MCP, integration. Gemini CLI provides an MCP and tool integration path. All three support extensible tooling models through plugins and allow for user-defined custom commands or reusable prompt workflows. A practical loop across these tools typically involves initializing the project, requesting a plan, running delegated steps through single or multi-agent execution, compacting the context as token usage increases, and finally clearing the session before starting a new task. Initialization is the phase where command line interfaces, or CLIs, standardize a workspace before any agent begins execution. While Claude Code pioneered the .md contract, Gemini CLI and Codex CLI have adopted a hybrid approach. The practical pattern remains consistent: start in an empty repository, run the tool's initialization flow, accept the defaults, and then inspect the generated metadata. Claude Code initializes a project around a claude.md contract, along with supporting folders for prompts and tasks. Claude.md serves as the human-readable control plane, defining goals, constraints, coding conventions, and operating rules for agents. Gemini CLI initialization centers on a dual-file setup. Project.yaml handles schema-driven settings, such as project identity and tool permissions. Meanwhile, Gemini.md provides the playbook of instructions and guidelines that the model follows during the session. Codex CLI initialization uses .codex/config.toml for environment and execution policies. For persistent guidance and agent behavior parameters, it relies on agents.md at the repository root, which the CLI checks automatically at the start of each session. Looking at the commonalities, each initialization flow scaffolds a predictable structure, establishes metadata, and creates a stable root for orchestration. The differences lie in the naming conventions. Claude and Gemini favor dedicated, brand-named markdown files like claud.md and gemini.md, while Codex uses the more generic agents.md for instructions and toml for system configuration. A standard verification routine after initialization involves listing the directory tree, opening the respective markdown, toml, or yaml files, running dry commands, and confirming that agents can resolve context paths. Workspace architecture determines extensibility and safe automation. It is essential to version control these files so that both the team and the agents share identical initialization assumptions. In command line interface workflows, an agent is defined as a reusable behavior profile. This profile encompasses the system role, task scope, memory handling, allowed tools, and the required output format. When examining Claude Code CLI, agent management is handled through the agent's command flow using markdown-friendly definitions. A typical agent.md file utilizes front matter for quick fields such as name, description, tools, and limits, while the body contains instructions for decision-making styles and refusal boundaries. The Gemini CLI Codelab demonstrates a configuration-first approach. Here, agent behavior is represented through project configurations, prompt templates, and run settings. This aligns with JSON or YAML schemas, which facilitate easy validation and version control. Similarly, Codex CLI documentation emphasizes a configurable execution policy. This includes specific instructions, command approval behaviors, sandbox constraints, and model or runtime options, making role and tool permissions both explicit and auditable. When choosing between Markdown front matter and JSON or YAML schemas, there are distinct advantages to each. Front matter allows for faster authoring and easier reviews within prose-heavy repositories. In contrast, structured schemas provide stricter typing and better continuous integration checks, making them safer for large team environments. Consider a practical comparison. A Markdown-based agent might define a database migration reviewer role with read-only shell tools and memory restricted to project notes. A JSON or YAML agent for the same role could include structured flags such as allow_network, set to false, approval_mode, set to manual, and an output_format, specified as a checklist. The shared takeaway across these platforms is to begin with minimal permissions and specialize by domain. Tool access should only be expanded when task evidence requires it, ensuring reproducibility, safety, and predictable behavior across different tools. Context architecture in Claude Code CLI, Gemini CLI, and Codex CLI is best understood as a series of layered buckets: user, project, session, and agent working state. The user bucket stores preferences and identity level defaults. The project bucket holds repository local instructions and files. The session bucket contains the live chat and tool transcript. Finally, the agent bucket manages temporary reasoning artifacts, plans, and intermediate tool outputs. All three command line interfaces separate these layers to reduce confusion. Persistent preferences should not pollute the task chat, and temporary execution traces should not become permanent memory. This separation is critical for preventing drift over long-running processes. Clear operations reset selected layers, typically starting with the session. For example, after finishing a refactor, running a clear command before starting a security audit ensures that stale assumptions do not leak forward. Compaction operations maintain intent while shrinking the token load. A 60-turn debugging session can be compacted into a short summary and key decisions, preserving continuity while reducing context costs and latency. While implementation details vary, such as default persistence, the aggressiveness of tool log summarization, and how export or import functions are exposed, the underlying similarities are significant. All three tools treat context as lifecycle managed state rather than an unbounded transcript. Plan mode serves as a critical safety and clarity mechanism for agentic command line interfaces, or CLIs. The standard workflow follows a structured sequence: plan, review, approve, and then execute. Rather than performing immediate edits, the agent first decomposes a request into ordered actions, expected outputs, and validation checks. Consider an example such as migrating login logic to OAuth and updating associated tests. A robust plan must identify target files, highlight risky dependencies, define specific test commands, and establish clear completion criteria. During the review phase, it is essential to confirm scope boundaries. This ensures no unrelated files are modified, no hidden destructive commands are present, and explicit rollback points are defined. Once approved, execution must strictly follow the published steps. If the results deviate from the plan, the process should stop to allow for plan revision and reapproval. When comparing tools like Claude Code CLI, Gemini CLI, and Codex CLI, we see consistent shared capabilities, pre-execution decomposition, human approval gates, and the generation of trace artifacts such as plan text, diffs, and command history to support auditing. Operational differences primarily involve how planning is invoked, whether through a dedicated command or conversational instruction, the number of approval checkpoints, and how plan artifacts are persisted for future use. A practical rule is to treat approved plans as reusable runbooks. By saving successful plans and parameterizing environment-specific values, teams can replay them for similar tasks to increase efficiency while maintaining control and compliance. Furthermore, attaching these artifacts to pull requests, or PRs, allows reviewers to compare the intended steps against the actual edits and test evidence provided. Custom commands represent a critical productivity layer built upon the base agent loop. They allow for the packaging of repeatable sequences, including context setup, plan requests, code modifications, testing, and summarization, behind a single trigger. In the Claude Code CLI, official documentation describes custom/commands. This approach enables teams to store command definitions directly within a repository, facilitating standardized workflows such as /shipfix or /refactor module using specific parameters. This file-based extension model is easy to version, review, and share across a development team. The Gemini CLI emphasizes the composition of reusable workflows by combining prompts with terminal commands. In practice, developers build templates that inject variables such as service names, environments, or test targets, allowing the agent to execute procedures consistently. This methodology supports robust workflow automation without the need to rewrite prompts for every session. Codex CLI documentation focuses on scriptable execution and configuration-driven runs. A common practical pattern involves wrapping Codex calls within shell scripts, make targets, or continuous integration jobs. This creates macro-like commands for domain-specific tasks, such as migration checks or the generation of release notes. While all three platforms support reusable command abstractions, parameterized templates, and automation chaining with existing developer tools, they differ in their implementation. Claude exposes explicit command registry ergonomics, Gemini highlights guided workflow composition, and Codex leans heavily on CLI and script integration patterns. In each instance, these commands can effectively feed planning steps prior to execution. Plugins represent the critical layer that transforms a command line interface, or CLI, agent from a conversational interface into an actionable tool. Across platforms like Claude Code CLI, Gemini CLI, and Codex CLI, a consistent operational pattern emerges. The model plans an action, the tool executes it, the model inspects the resulting output, and then continues its reasoning process. The common capability set for these plugins typically includes 4 key areas. First, file system tools allow the agent to read, write, search, and edit project files. Second, execution tools enable the running of shell or code commands for testing, building, or linting. Third, connector tools facilitate calls to external services through application programming interfaces, or APIs, or protocol adapters. Finally, permission gates ensure user control, determining whether actions run automatically or require explicit approval. While the core pattern is shared, implementation differs across platforms. Claude Code CLI emphasizes explicit tool control, featuring configurable permissions and integration with external tool providers, such as Model Context Protocol, or MCP-compatible servers. This allows teams to expose internal systems safely. Gemini CLI workflows focus on task execution loops, where the agent combines local operations and command execution to complete coding tasks efficiently. Codex CLI documentation highlights structured execution with approval or sandbox-style controls, focusing on reproducible, command-driven workflows for code generation, edits, and validation. Consider a practical workflow: refactoring an API client, running tests, and then opening a pull request draft. In this scenario, the agent utilizes file tools for edits, execution tools for tests, and API connectors for repository operations. Ultimately, the plugin design dictates the level of automation and the overall behavior of the agent. Output style is not merely a cosmetic choice, it is a critical factor in determining whether humans or automated systems can safely consume results. When working across tools like Claude Code CLI, Gemini CLI, and Codex CLI, we must consider three primary output contracts. First, Markdown or plain text is ideal for interactive use. Second, JSON is the standard for scripts and logging. Third, structured schema output is necessary when downstream systems require fixed, predictable fields. As a practical rule, choose Markdown when iterating, JSON when piping data to other tools, and schema-validated output for production-level integrations. Configuration is typically managed at two distinct scopes: global defaults, set via configuration files or environment variables, and per-run overrides, managed through command line flags. This flexibility allows one agent to remain concise while another emits detailed diagnostics within the same workflow. Verbosity controls adjust the density of detail without affecting the correctness of the task. Low verbosity is faster to scan, whereas high verbosity is better suited for audits, postmortems, and prompt debugging. The choice between streaming and buffered output is an execution control. Streaming displays tokens or progress immediately, which improves responsiveness during long generations. Conversely, buffered output waits for the process to complete, making it easier for parsers that expect a single complete object. Consider these integration patterns. In development, use Markdown with streaming and medium verbosity. For CI steps, utilize JSON or structured schema with buffered output and low verbosity. For compliance reviews, structured schema with high verbosity provides traceable fields. Ultimately, treat the output mode as an interface contract rather than a simple presentation preference. We begin by focusing on the orchestration pattern rather than the specific tool. In Model Context Protocol or MCP-style workflows, a single controller agent is responsible for planning tasks. It delegates these tasks to specialist agents and subsequently aggregates the outputs into a final artifact and a comprehensive log. Across the Claude Code CLI, Gemini CLI, and Codex CLI, the fundamental shared capability is command line automation. Each of these tools can operate within repeatable terminal flows, accept structured instructions, and be seamlessly embedded into scripts. This functionality enables the creation of practical pipelines, such as a sequence moving from a planner to a researcher, then to a coder, and finally to a reviewer. A typical workflow consists of 4 key stages. First is the planning stage, where subtasks, acceptance criteria, and handoff formats are defined. Second is the delegation stage, which assigns role-specific prompts or commands to the appropriate agents. Third is the execution stage, where agents run their assigned tasks, often in parallel when it is safe to do so. Finally, the aggregation stage merges the results, resolves any conflicts, and records the provenance of the data. The primary differences between these tools lie in their built-in ergonomics rather than the core concept. Claude Code CLI emphasizes interactive coding workflows with explicit command line controls and integrations. Gemini CLI patterns focus on prompt-driven task execution and tool utilization within terminal sessions. Meanwhile, Codex CLI documentation highlights code-focused execution controls, approval processes, and scripted runs that are well-suited for continuous integration or CI-style orchestration. To see this in practice, consider a scenario where an API specification is generated by Agent A, endpoints are implemented by Agent B, and tests are executed by Agent C. The process concludes by consolidating summaries and failures into a single release report. This represents the practical application of delegation and pipeline coordination in modern software engineering.